Hey, this is Max from BFD Systems, and today we're going to go over an unboxing and pre-flight of a GD-40 airframe. This is one of our larger airframes. It's commonly used for industrial as well as cinema purposes. The aircraft comes in two cases. This would be the body case here, which holds the landing gear and the main center hub, as well as a transmitter and other accessories. And this case here is for the arms, which then are modular and strap on the outside. So the first step is we're going to assemble the retractable landing gear. So we're going to take out, this would be the skid, and these would be the tubes for the retractable landing gear. There is a small sticker on each tube that will match up or correspond with the skid here. And the reason we do that is because sometimes there's slight variation in the carbon, and this will ensure that the cam lock is the appropriate tightness. You can kind of verify that's the appropriate tightness by trying to rotate this tube, and if it rotates, then you can always adjust the cam lock there. So now that we have the first skid and down tube assembly, we're going to take out one of these mechanical boxes. We line up the down tubes here, and then we lock the cam locks. So there's two of these, one for either side of the aircraft. We can put that one right there, do the other one as well. So this is the body hub, the main center hub of the airframe. Each arm will attach to one of these posts here, which are labeled, and then on the side, these are where the retractable landing gear will go. These are identical, so it doesn't matter which one goes on which side. There's basically 4 posts there that kind of line up and hold the landing gear. So once we get that first one, we can kind of rest it on there, and then we'll get the second one. So there you go. All right, so now that we have the landing gear attached here, we can move out these GPS pucks. These are just little thumb screws, so you can loosen and tighten. They don't have to be crazy tight, just finger tight. You can just kind of make sure that there's no play there. We're going to use the supplied landing gear screws to secure the landing gear. The landing gear screw and the arm screws look very, very similar, so you want to be cautious about which one you're using. This is the landing gear screw. It has a little bit more of kind of a collar that you can see like so. And this is the arm screw, which does not have the collar. In addition to that, there's a little carbon wrench, which is what you use to kind of secure the screws on. So we'll start by putting the screws in the leg, and it helps to kind of lift up on the leg a little bit so that there's no tension on the screw. It should go in really, really easy. Make sure you're not cross-threading them. There's one that goes in on top, and there's one that goes on the bottom. It's much better to do this step before you put on batteries or arms or any other thing that are going to make the drone heavy, because it can put tension on the landing gear. All right, so once those are finger tight, you can use this carbon wrench and just give it a little bit like 1/8 of a turn just to snug it up. You'll see that this piece here is the kind of mechanical lock. That's what actually holds the drone up. You don't want the weight of the drone being held on these linear actuator. So the way that we kind of check that that's locking, there should be a little bit of a knee. It's about a 1.5 degree knee in this direction. And you can kind of check by putting a slight bit of pressure right here, make sure there's no slop. And you can kind of put a little pressure on and just make sure that this leg is locked in this position. That way, the whole force of the lock mechanism is holding the drone. If this was indented a little bit, that would mean that the force of the drone would actually be on the linear actuator, which we don't want. So you can kind of check by just applying slight pressure, making sure that they're locked and good. And in this case, they are. These are, you could use 16,000 or 22,000s are the most common, but you could use any kind of 6S LiPo. And what we're gonna do now is load up 2 batteries and do a compass calibration. The reason we're doing this now is because once you put the arms on, it gets a little bit unwieldy and large. So it's easier to do a compass calibration if you don't have all those arms on there. Some people will like to be sticklers and put the arms on so that the compass is reading the magnetic field of the actual motors themselves. But with DJI, we can't really tell a big difference in how that affects the compass calibration. It's minimal, so it's not really even worth it, in our opinion. We use Tattoo Smart batteries. It's really important that whenever you're using batteries in either parallel or series, in this case we're doing both, we want to check to just make sure that the voltage is about the same. That's what these are, these little indicators. So these are both at storage, but if one of these was full and you plugged it in to a parallel or series connection, it would instantly drain into the other battery really fast. So you want to make sure that they're about equal. The other thing that's important to note is these 4 pairs have to be matched to one specific battery. You cannot plug a battery into this one and into this one. It will short out. So it's very important that you take great caution with that. The way that these batteries connectors work is there's an anti-spark plug in the positive side, and you have to plug in the ground side first to allow the anti-spark to work properly. When we plug in this first battery, nothing's going to happen because the drone is running off a series connection. So at this point, we have one battery plugged in. There's no series connection made. Second battery is about to be plugged in. At this point, once we plug this positive into this discharge lead, we'll have a series connection with these 2 batteries. Before we do that, with any RC remote aircraft, we are going to turn on the transmitter first. Your transmitter may vary depending on your options, but this is a light bridge transmitter, which is quite common. And this will use an iPad as your screen for your camera, as well as for controlling the drone and just kind of having some general information. So aircraft's not connected, so nothing will come up yet. So we've made that connection. There's no motors on the drone right now, so you're not going to hear any beeps. You will hear a few fans whirl up, and you'll see the LED indicator light up on the back of the drone, which is giving you the status of the DJI flight controller. And that will kind of indicate that the drone's powering up. In the beginning, you don't want to touch the drone because the IMUs are calibrating, so it's really important that the drone is being held still. It's important to note that these ends of the arms are live. This is 50 volts direct current. It won't really shock you, but it's a good idea not to touch this, not to have any metal contact. Also important to know that once these are plugged in, do not plug the arms in while the batteries are plugged in, because that will cause a spark, which is very much why we use the anti-sparks here. This is just the same as any other DJI product that uses a light bridge controller. So it'll tell you the number of satellites that you have and the status of the aircraft. So right now we're indoors, so we're gonna have to kind of fake a compass calibration. But essentially what we're gonna do is we're gonna go into the app and we're going to calibrate the compass. It's gonna ask you, are you sure you wanna calibrate? And you hit OK. So I don't know if we're gonna get an actual compass calibration in here because we're inside, but this is the reason why we don't have the arms or all 4 batteries on. Because you gotta hold the drone horizontally, and then you gotta flip the drone vertically. And you wanna make sure your batteries obviously are nice and secure. Before we put any arms on, we're going to power down the drone. If you disconnect the series connection, the drone is powered down, but just to be extra certain and to avoid mistake, you can just take the positive leads and unplug them. Each one of these arms has just a label, A, B, C, D, to put the arm on. Just kind of work it back and forth until it kind of clicks all the way in. You don't see a gap. We like to put the arms on, kind of counter each other to balance the drone a little bit. There's two guide pins, two steel guide pins on the side. So we put those in first, make sure those are lined up, and just kind of pop it in. And again, it's important that the battery series connection is not made while you're putting these arms on. Otherwise, you get a nice little spark when you join the printed circuit boards there. All right, now that the arms are on, we are going to take these screws and we're going to insert them just like we did for the landing gear. Again, making sure that you're using the arm screw, not the leg screw. When we are putting the screws in, it's important to just put a little bit of pressure up on this motor. It takes the weight off and it makes sure that there's no binding in the screw. The screw should really go in super easy and not have any friction. The way that we recommend assembling this frame is if you're working with two people, which often with something like this you will be working with two people, but put all the screws in first and then go back and tighten them with the wrench. And that way there's no confusion over which arms were tightened or which ones weren't. All the screws are in. We're going to take this carbon wrench, just like for the legs, and just apply a little bit of force to tighten them up. So now that the arms are on, we're going to get the other two batteries. And we can just plug in the ground wires first. And you're making sure that each battery is only being plugged into a pair. Okay, so at this point, we want to make sure these are all battery 3, A, B, C, D. And we kind of just check to make sure that all the voltages are about the same, and that way we're not draining one battery into another one. These batteries should be considered one battery. These two are in series, these two are in series. So the way you should really think about it is this is battery 1 and battery 2. So once we are ready, we can get these batteries ready to get plugged in. At this point, the drone is not powered. Even though these are plugged in, this series connection on either one of these batteries has not been made. So before we do that, we're going to turn on our transmitter, and then we are going to power up the drone. It's battery 1. It's battery 2. So we powered up the aircraft. The default configuration for our aircraft are green lights on the front and red lights on the back. It's kind of a preference thing for what you're interested in. So if you have a request, let us know before we send you the aircraft. I'm going to give you the broad overview of how we do this, but you're going to have to kind of set up your own method for doing your pre-flight. So this is kind of a broad overview. But we'll start at arm A, and then we'll work our way around. Now this is the front right arm. And what we're going to do is check for any cracks or a delamination in these propellers. These props are good. The other thing that we're going to check is any play in the motor bell housing. And the way you can check that is take a nice hold of both the top and motor, and what I'm doing is torquing it left-right and just seeing if there's any play in the bell housing or the motor mount. At this point also, it's good to just kind of look over the hardware. These are, when we assemble them at BFD, they're all using red Loctite, so they're pretty hard to get undone. But it's always good to just check to make sure there's no hardware issues or any screws that look like they're backing out or stripped or anything like that. The other thing that we'll do is kind of make sure that there's no cracks in any of the arms or any delamination in the carbon. We'll kind of make sure that these screws are tight. So we're basically going to do what we did with arm A on all 4 arms. So checking the propellers, making sure that the motor mounts are secure and that there's no play in the motors. When we get to this side, we're going to check the landing gear to make sure there's no play in the mechanical box. Check that the screws are secure. If we look in the side, we'll see the light bridge controller here. Make sure that the light bridge is powered. We have a flexible light bridge antenna. Make sure that that is secure. We have a optional 5.8 transmitter. Make sure that that antenna, if you're using it, is secure and in place. If you have the optional 5.8 transmitter, this is the transmitter. If you need to change a channel, there's a button right there. But this will indicate the channel and the band that you're on for your 5.8 transmitter. This is your DJI status light. This tells us the status of the aircraft. If there's an issue or what the flight mode is. Green, what we're seeing now, is indicating that we're in GPS mode, which is your most common flight mode. These indicator lights here are your low power distribution fuses for things like the LEDs, the landing gear, and the FPV transmitter. Depending on your options, you might have a payload power, which would also have its own fuse. Now, between arms A and B in the front, right underneath the BFD logo, there's a little FPV camera here. So you just want to make sure the lens, sometimes there's a lens cap on there, you remove that lens cap, make sure that that camera is pointed however you need. You can kind of just adjust it if you want to point it straight down, or if you're going to be ripping around, you can kind of point it up so that you can see where you're going as the copter pitches forward. But at this point is a good time to check that FPV camera to make sure it's good to go. So you've done your pre-flight, your basic pre-flight of your aircraft, and now you're going to want to mount your payload. Now, depending on what you're mounting underneath the drone, there might be some variation. A Preflight Movi Pro or Movi Carbon will have a toad in the hole. A DJI Ronin 2 will have their own little dovetail. So before securing, you can kind of just check to make sure that your damper plate is secure, all the hardware looks good, all the damper balls look good, and then you're going to attach your payload underneath and make sure that's secure. All right, so now that your aircraft is secure, you've secured and checked your payload, you're ready to go fly. It's a good time to note that this is not a toy, and this video is not the complete instruction manual for this aircraft. Know the limitations of the aircraft as far as what your payload capacities are, what your wind capacities, or other weather considerations. Know where you're flying, make sure that you're flying in a safe place that's not going to break any local or federal laws. If you have any questions on this aircraft, the setup, the operation, the maintenance schedule, or sales inquiries, contact us by going to bfdsystems.com and we'll be happy to answer any of those questions.